Hot diggity dog. All right, we at it again here. This time, this Wimshurst generator slash these names right here. These two guys are the first ones to come up with the Wimshurst, and before Mr. Wimshurst came up with it. But besides the point, I went on ahead. I've been playing with this for about 2 weeks now, so I got a little something to say about it. I took it apart a little bit. Usually you'll have both sides spinning, but I got this one taped down because what I was trying to do, or what I did do, was I wanted to get one side spinning alone and still create the electrostatic effect. Because if I can do that, then there's nothing stopping me from connecting the electrostatic effect, or this is the circuit for what I got it for with though here. Connecting that with this bad boy in some type of form, fashion, or way. I mean, let me see. Let me see. So, like I was saying, I'm gonna go ahead and let this thing go now. Only one side is spinning, and it's still discharging. It still has a static charge with the way I have this set up here. So the way I have this set up here is I have the same configuration of how it came with, because you got to have the stabilizer bar to I'm sorry, the neutralizing bar to keep the sides how was it explained, to keep the sides neutral here. So what happens is when it hits this neutralizing bar, it uses ions to attract and repel, and due to the capacitor formation setup this is in, with the metal on both sides, and then you have the insulator in the middle, which is air in this acrylic glass here. It allows for a capacitive effect to happen, and you get an attractive charge on one side, and you get a repelling charge on the other side, in a sense. And then when it goes over these collectors here, it discharges, and then it restarts over again as it gathers the electrostatic effect of these two plates being close to each other and going at the speed they're going or whatnot. So yeah, it's just the law of magnetism at play, along with what's going on here. But so basically on this backside, I had to put some aluminum tape here to connect these leads to where I can make like a mini small capacitor plate on this side, that's what this is here. And then you have to curve it around with the little piece of copper here to touch this side to neutralize, or allow for the repel effect of the ions to build up more. Because what happens is you're still attracting ions on this side, positive. We're going to just say this is positive right here on this side. Also, you got to remember, with this side is positive, this side is negative, or vice versa, depending on how the charge carrier is going. But so you put this on this side right here, and it allows for any residual, let's say, negative charge on this side to be discharged on this side because it's pulling towards it now. And along with that, it repels its own at the same time. So it goes over this collector here, and it collects it in it's zero right here at this point in time. But due to the fact that it's still in this capacitor range right here, right over the bar, neutralizing bar, and right under the collecting bar, it allows for a negative push to be pushed off of this capacitor on this side and pushed across here to allow the amplifying and the more separation of the charges to gather up. And the more that happens, as far as these small little these small little metal aluminum tapes passing over, it just builds up. It just keeps building up, along with the friction of the item moving in and out of capacitance of each one of the plates. You see, the thing is, when you also pull plates apart, capacitor plates, it allows for the voltage to be turned up at the same time also. So you actually have a couple of effects going on here. I really don't know how to explain that effect. All I know is when you put two capacitor plates together and pull them apart, the voltage goes up out the air, goes up sky high, but the capacitance goes down. So it's kind of like transforming in the form of capacitors as far as the step up or step down, depending on where you move. But due to the fact that we're going over each one, I'm out of, okay. It took a while for that to start up because with me touching this, it discharged some of the plates and the ion carriers got had to build back up again. But once the flow of direction of the ions built back up, it started going again. Separate that. Let me turn off some of these lights here. See if you can see it now. Yeah, you can still see it. Yeah. So now it's just a steady charge going when this shunt bar isn't connected, because what this allows for it to happen is these two capacitors right here, which are Aladdin jars, these two capacitors, it allows for them to be connected in series and the charge gets a lot bigger. But when they're connected separately and they're collecting their separate charges, the buildup would just automatically discharge after a while anyway. So if this charges a lot quicker this way, it's got to build up again. I might have to start it. Okay, sometimes the electrostatic part of it don't want to work, so this is what I do with it when that happens. I go and grab me something to make the electrostatic pop off. And rub it a little bit. And then wave it over what I'm trying to get to work or whatnot. Wave it over the plate. Then we try it again. There it is. And then it starts up. Because we had to get the charge carriers separate. When you're dealing with electrostatic charges or electrostatics in general, you have to allow it to, you have to put a charge on it to where it's going to flow. This is why it doesn't have any diodes. It's just kind of floating. If you look up the names on YouTube or whatnot, and what I had given you in the description here, you'll be able to find everything you need. But yeah, you can see the corona gathering as the charges separate. And the thing is, you don't even need all tiny wires. Oops, orientation is locked. Oh, okay, I wasn't trying to do that. Okay, cool. Trying to catch that side. Let me turn this light off here. See if I can catch it now. See, I can catch this side right here, because this is the charge collector that's going to the capacitor. But I can't see it on this side. I might have to turn off more lights here. Hold on. Dang. I don't want it to be too dark in here. Just turn that down like that so I can see. Okay. All right, there it is. I don't know if you can see it on this camera. Let me connect the shunt bar so it'll spark harder. Okay. So you see that spark going across there. And on this side, it's still gathering up on this back side also. So that's proof right there that, so I got the negative charges gathering up right here and the positive charges gathering up right there. So that's proof that this is biased by separation. You could have seen that spark from there, then you can see the spark on that side. It didn't spark on this side. It sparked on this side and it sparked on this side. Okay, it didn't spark on that side, so you can see the charge separation happening when it's happening. But yeah, this is what we're playing with here. Um, the reason I want to mess with this is because unlike coils, capacitors, it allows for non-bogging. Like if I was to be trying to pull energy, I could pull a little bit extra energy now if I was to put that on the Bindini motor along with it spinning, because there's already something moving, whether it's a solenoid moving or a spinning disc like this, or even a ravioli can cylinder. You can put it on that and move that in an electrostatic motor way, but in reverse. But with these this will allow for a little bit more energy to be collected. This will it just allows for a lot more to be open. That's all. I'm trying to put together all the electrical systems that all electricians and everybody try to neglect. And what I'm trying to do is trying to collect all those let's say different phenomena that happen with electricity, and put it in a capacitor of its own, and then add it to the system to where it can run cold without forcing phenomena that happen with power or energy to not happen. You know, we want this stuff to be flowing. But yeah, the shunt bar or the closed shunt bar, that's this right here. That's the back side of it with the big capacitor here. And the front side, you can see that already. And these are the Leyden jars or the capacitors, these big bad boys that go into the collectors here. You see it goes into the collector. And just by it being in the vicinity, it collects it and it builds it up. I wish these were just a little bit closer. Maybe I can bend this. I might do that later. Wish those were a little bit closer. So that way the charge wouldn't have to build up so much on the plates before it discharged into here and helped fill this up basically like a water jar. That's how this fills it up. It fills up energy like a water jar. You know, usually you hook up a 9-volt battery to something, and no matter how many capacitors you have, it's still going to be 9 volts unless you hook them up in series. Well, this is a series connection of that, I want to say. It fills it up just like water. If I was to pour water in there, that's exactly how this fills in the formation that this gathers energy. So yeah. All right, I'm going ahead and end it. They don't let me go live, so I had to try it out. It's kind of hard freestyling, but we got it out the way, though. We got it out the way. We got it out the way. Okay, how we stop this thing? Yo, how do we stop this? Yes.